Okay, let's start again. I didn't share the screen. So this talk will be about low-cost MCUs running RT-Thread. First, we will look at the available hardware. Just a quick rundown of two options which are out on the market. The first one is the Puja 32 F002, which is at the 6K quantity in the QFN20 package with 80 IO pins, 9.5 cents. The WCH offering, which for comparison here, is 13 cents or slightly higher cost. What's great about the Puja is an ARM M0 Plus, so very familiar from the architecture and programming. WCH is a RISC V2A with good documentation, so also easy to work with. One of the compromises with these low-cost MCUs is they're relatively slow, 24 megahertz. On the upside, in the last years, the flash and RAM significantly got increased to the point where it's no longer a constraint for most applications. 20 kilobytes of flash and 3 kilobytes of SRAM on the Puja is enough for most gadgets. Also, strong point is the supply voltage. It works with 1.8, 3.3, and 5 volt logic system without logic shifter and the like, further reducing the potential bomb. And you can get them in up to 18 pin packages, LO packages, which is also the most expensive one, which is still under 10 cents. If you go with smaller packages, the price also drops significantly. But then again, you might run into a situation where you are pin limited, and some of them are even tube packages isn't ideal for manufacturing as it creates overhead at the assembly house. The peripheral is SPI, UART, I2C, ADC, so what you would expect also from basic MCU, still good enough. One of the downsides of the F002 is it doesn't have DM's direct memory access, which is available if you go with the 003, which is slightly higher cost, but still very reasonable. And as mentioned before, they have made significant advances in the last 5 to 10 years. I mean, half a decade ago, it was 8-bit microcontrollers at this point with a visible few bytes of SRAM and maybe kilobyte of flash or single programmable memory. So this also reflects in the launch date of 2022 and 2023, and I would expect there's more to come in the future in this price range. Another aspect for the Puja is another compromise is the power consumption with 1.1 milliampere at 24 megahertz. It isn't efficient. So for battery powered application, you very likely would want to choose a different MCU. But for everything else, it's a great option. And another issue, even with sleep and stop mode, power consumption doesn't drop low enough to make it feasible to run on batteries. On the right side, there's a few dev ports and programmer. You don't need anything special for the WCH and WCH link, which is also very affordable. And for the Puja, it's an ARM M0 Plus. So most ARM development tools work with it, like the Jagger J link or DAP link, which is on the picture. So why are we still not using them, or why do people still not use them? Some say the capability is not there. They are very limited in resources, which has changed these days. So this no longer is a valid point. Others say at the volumes I run, it doesn't count. On the next slide, we will see that also at lower and mid volumes, it can make significant impact. It's quite difficult to work with them, which still holds partly true, but there's more and more English documentation and examples available. For example, WCH provides nearly for every function on the chip a working example code on GitHub. The other point, which is very valid, is the high cost of validation and learning to use them, which should be seen as a strategic long-term investment to bring the cost down in the long term and stay competitive. One of the issues nearly all of these microcontroller plague is they don't have a long-term availability commitment, so they can be discontinued at moment notice. But the last year have shown should keep for difficult to replace parts inventory, so you can mitigate it even though it has some cost and capital bound. So quick example, we have a product which has a potential retail price of $20. We need 3 times the production cost to be profitable. We are already down at 7. From this, we have to pay assembly, testing, and the components. So you might end up on the electronics BOM with $3. With a 50-cent microcontroller, this would be 1/6 of the entire available BOM. If you can use a 9-cent microcontroller, it's just 3 cents. In this price class, 41 cents can get you a long way or be the make or break of the product. So even for relatively low volume manufacturing, this can be a very good way to get a feasible product that has a chance on the market. So the quick rundown of the microcontrollers are now done. We can talk a little bit about RT-Thread. On the left, we have the RT-Thread, the full featured one. On the right, RT-Thread Nano. You would want to compress what RT-Thread Nano is in one sentence. It's basically everything removed besides the bare minimum, which is more likely a kernel with a little bit around it, which is enough for most applications, and you can add stuff back into it with a little bit of work. Big upside is you only need 3 kilobytes of flash and 1.3 kilobytes of RAM. If we remember, we have 4 kilobytes of RAM and 20 kilobytes of flash on the chip. So we have reasonable resources to work with for our applications we want to run on them. So Future provides packages for Kyle MDK or Microvision and IHR embedded workbench. In the following, we will discuss it on Kyle, which you can get a free evaluation license for personal use. After you install the IDE, you can download the package for the Puja and RT-Thread, which is, if you look at on the right, 3.15 from 2021. So you might want to manually update it, but for getting started and play around, it should be fine. As mentioned, this is a normal MDK dialog where you select the parts you want, software components, and targets. You need to, as mentioned, there also are still limitations in the usability. Like, for example, we have to manually adjust the RT heap size, which is by default 16 kilobytes, which is way too much for this chip. So we have to drop them manually in the config.c file to 2 kilobytes to get it up and running. Another issue with those chips is while you can get bare minimum implementations of RT-Thread from some of them, but not all, most don't have a full BSP package. So you will run into stuff like this, which would be a live demo of Microvision would run, where you see in the comment left that the tick configuration is not done, and you have to manually do this, implement it to get it up and running with RT-Thread, which brings us back to the open Future, where you can see all the documentation and they are in HAL. So what you now would need to do is either implement the function yourself or bridge the Future HAL to the RT-Thread Nano. Both is feasible, and once you get it up and running and have a few packages included, the workload drastically reduces and you can work with them quickly. So this would be the point for the live demo, but due to the Microvision not working, I can't do it, where we would go in and fix this really simple issue by manually writing the code required to get the tick counter working. So that's the quick rundown of the topic. Yeah. Any questions or not? Okay, doesn't seem like this.